We only have to look up at the moon to see the remains of a cataclysmic collision between two early planets, billions of years ago. Now scientists suggest evidence may also be deep beneath our feet, as the remains of that ancient planet lurk near the Earth's core. In the 1980s, geophysicists discovered two gigantic, unexplained blobs of material in the Earth's mantle. Seismic readings indicated these regions, each spanning thousands of kilometers wide, were far more dense than the surrounding mantle and likely had much higher iron content. These mysterious structures were labeled large low-velocity provinces, or LLVPs, since their density slows down seismic waves as they pass through. The leading hypothesis is that these LLVPs are the partially melted remains of ancient continental plates that sank beneath Earth's surface. But a new study from Caltech proposes a more alien origin. Perhaps, they posit, these iron-rich blobs are fragments of a long-lost planet that Earth swallowed. The story sounds crazy, but it's not without some scientific basis. It's generally thought that Earth did live through an apocalypse of planetary proportions about 4.5 billion years ago, when a Mars-sized planet named Theia slammed into it. This cosmic smash-up is believed to have created the moon, and may even have delivered most of Earth's water. In the aftermath of this collision, it's usually thought that material from Theia mixed with Earth's mantle, so that the planet and the newborn moon shared the same general composition. But the Caltech researchers suggested that instead, large clumps of Theia stayed intact and sank towards Earth's core like blobs of wax in a lava lamp. The scientists modeled a range of different possible scenarios for what Theia might have been made of and how it collided with Earth. And sure enough, the simulations resulted in the creation of both the moon and the LLVPs. After the collision, while Theia and Earth were one big gooey mess, parts of Theia's mantle clumped together and crystallized into two iron-rich blobs within Earth's. The simulations showed that energy released during the impact melted Earth's upper mantle and crust, but didn't reach the lower mantle, leaving it cooler than other models have predicted. That let the Theia blobs stay intact while they drifted down to where the mantle meets the outer core, where they've lurked ever since. It's an intriguing story, but one that would need further investigation to confirm either way. In future work, the researchers plan to study how these structures might have influenced Earth's history.